Welcome back, everybody. We are now up to multiplying and dividing integers or signed numbers. Now, integers, as you know, are positive and negative numbers. What you need to do in your brain is you need to make kind of a wall between the adding and subtracting rules and the multiplying and dividing rules. You see, in some respects they're similar, but with the multiplying and dividing, I've written the rules right here. These rules only give you the sign of the answer. So a positive multiplied or divided by a positive is a positive. A negative multiplied or divided by a negative is a positive. A negative multiplied or divided by a positive is a negative. And a positive multiplied or divided by a negative is also a negative. Now, I'm going to explain these rules in a little bit and why they work. But for the moment, I want to go on ahead and apply them. Again, remember, they only give us the sign of the answer. Okay, I've got 5 example problems written here. The first one is 7 times negative 10. Remember, when a number is next to a parenthesis, that means multiply. So the 7 is positive, the 10 is negative. So a positive times a negative, the sign of the answer is going to be negative. 7 times 10, we now just do that arithmetic, is 70. So the answer there is negative 70. With the second one, we have a negative 2/3 times 3/5. Well, I realize this isn't an integer, they're two real numbers. We still use the following rules. We have a negative, and we're going to multiply it by a positive. The answer is a negative. Now, we have to do the fraction arithmetic. Don't forget with fractions to see if things can cancel. Can anything cancel with the 2 from the top and the bottom? The answer is no. Can anything cancel with the 3 on the top and bottom? The answer is yes. Both of these can be divided by 3. They cancel out and they turn into 1s. So 2 times 1 is 2. 1 times 5 is 5. So the answer there is negative 2/5. On the third one here, I have a decimal problem. Again, not integers, but the integer rules apply. I have a positive and a negative. A positive times a negative is a negative. So we know the answer is going to be negative. Now I'm going to spare you writing out the arithmetic. 5 times 13 is 65. And we have to place the decimal point in the correct spot. There are 2 decimal places in the problem, so there needs to be 2 decimal places in my answer. So it'll be negative 0.65. A lot of times you'll see a 0 there in front, so 0.65 or just 0.65. They're both equally correct. And again, don't forget about that negative sign. Now on the third one, I've written a division problem here. Negative 28 divided by negative 4. Negative and a negative, when we look up here, negative and a negative is a positive. Again, multiplying and dividing, you kind of get a 2-for-1 deal here. The rules work for both. So the answer is positive. 28 divided by 4 is 7. The fifth one is 3 times negative 4 times negative 5. Now there's 3 numbers being multiplied there. First of all, let's take them in pairs. So I just literally cover up the negative 5. 3 times negative 4. A positive times a negative, that answer is negative. That's going to be negative 12. Now we're going to do negative 12 times negative 5. A negative times a negative is a positive. And 12 times 5 is 60. Now, why are these rules like this? Where did this come from? Need a little board space here. The positive times a positive, that's the easiest one to explain. 3 times 4. I'm going to use 3 times 4 as my example for all of these. What does 3 times 4 mean? It means 3 plus 3 plus 3 plus 3 if we go back to the definition of multiplication. It's how many times is 3 added to itself. But we just want to know, why is it always positive? Well, think about it. A positive plus a positive plus a positive plus a positive, that answer is always going to be positive. What if I did, and I'm going to jump down here, negative 3 times 4? This here is going to be this rule right here, a negative times a positive. Well, that's going to mean negative 3 plus negative 3 plus negative 3 plus negative 3. When you keep adding negatives, your answer is always going to be negative. Think about it. If you borrow $3 and borrow $3 and borrow $3 and borrow $3, you keep borrowing $3, you're going to owe money. Nobody's going to let you out of that unless they're really nice. But in essence, in this case, you would owe $12, so it would be negative 12. Now I'm going to cheat a little bit on the next one. What about 3 times negative 4? You might be saying, okay, how do you show that the other way? I'm going to use the commutative property, which means you're always allowed to flip multiplication. So I'm going to rewrite this as negative 4 times 3, negative 4 plus negative 4 plus negative 4, and hence a negative plus a negative plus a negative. The previous explanation still applies. The last one is a little bit more difficult to explain. You just have to really think of it as opposites. So negative 3 times negative 4. So it's going to be negative 3 plus negative 3 plus negative 3 plus negative 3. But we're doing this a negative 4 times. Well, if you do this right here, you would end up with negative 12. But you're doing it a negative number of times. A negative negative is a positive. I admit that that explanation takes a lot of time and you really have to think about it. Anyway, good luck with multiplying and dividing, and hopefully you'll watch the next video if this was helpful.